Welcome, future math legends. Today, we're diving into the mysterious yet magical world of integer exponents. It may sound serious, but don't worry. There will be math, metaphors, and maybe even a mild pun or two. Buckle up! Exponents are like the energy drinks of math. It's a compact way of repeating multiplication, because life's too short to rewrite a million A's. An exponent tells you how many times to multiply a base by itself. For example, a to the third power means a times a times a. Special rules include a to the 0 equals 1. A to the 0 equals 1 is one of math's fun mysteries. Just accept it. It works. Like Wi-Fi. And a to the negative n equals 1 over a to the n. Think of a to the negative n as an introvert at a party. As soon as things get loud in the numerator, they quietly sneak downstairs to the denominator where they can act normally. A to the n is also read as a to the nth power or a to the power of n. I just use a to the n. I prefer to save power. A to 1 is equal a. A to 2 is a squared and a to 3 is a cubed. We are lucky mathematicians stopped naming after 3. In the exponential expression a to n, a is the base and n is the exponent/power. Okay now, with great powers, come great rules. When two exponents fall in love, same base, they just add their powers. It's basic exponent dating mathematics. So when multiplying exponents with the same base, we add the exponents. For example, a squared times a cubed equals a to the fifth. When raising a power to another power, we multiply the exponents. This is math's version of inception. You raise a power to another power and suddenly you're 3 layers deep and nobody knows how you got there. But hey, it works. Just multiply the exponents and try to wake up. For example, a squared raised to the third power becomes a to the sixth. When dividing exponents with the same base, we subtract the exponents. If product rule is about teamwork, quotient rule is about sibling rivalry. So a to the sixth over a squared equals a to the fourth. A negative exponent means we take the reciprocal. Ironically, introverts find it difficult to reciprocate. For example, a to the negative 3 becomes 1 over a cubed. This rule is like Oprah giving out exponents. You get a power. You get a power. Everybody gets a power. When both the base and coefficient are inside the parentheses, we apply the exponent to each part separately. When we raise a fraction to a power, we apply the exponent to both the numerator and denominator. It's like a breakup. A and B are going to be emotionally damaged to the same exponent, I mean extent. Negative exponents in a fraction flip to the opposite position and become positive. Nobody likes negativity. A negative exponent on a fraction flips the fraction and applies the exponent as positive. This flip is sponsored by Newton's third law. For every math action, there's an equal and opposite reaction. Now, simplify this like an exponent master. In this example, we simplify step by step using the product and quotient rules. We end up with 1 over a. Another socially awkward a who sneaks downstairs, because everybody in the party is staring at the negative sign stuck to his forehead. Now it's your turn. Try to simplify this expression using the laws you've learned. Here you are acting as a divorce attorney. We apply the power rule to the numerator and denominator. The final answer is 4a to the fourth over 9b to the sixth. These guys look better off separated. Try to simplify this expression using the rules you've learned. If I were you, I would start by taking a deep breath. Then I would take care of the disturbing mess inside the brackets. Pay attention to the order of operations. I tried solving math without order of operations once. Now I see a therapist and so does my calculator. Congratulations! You've just mastered the power of powers. Use it wisely. And remember, the day the power of love overrules the love of power, the world will be exponentially better.